Hello, and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. For today's show, we have an absolute veteran of the EV industry, particularly early in electric commercial vehicles, which is obviously something that's a massive topic now. And the really special thing about this fella is he's a fellow Northerner, and not just a Northerner, he's also from my hometown of Blythe, which has been in the headlines a lot recently because of the announcements to do with battery manufacturing up here. It's also where Avid is based. But it gives me great pleasure to welcome to the show Doug MacAndrew. Welcome, Doug.
Thank you, Ryan, for giving me the opportunity to have a chat with you about EVs and their applications, and just some history as well.
Yeah, well, so if we can get kind of stuck into it, obviously you grew up in Blythe in Northumberland, so maybe just a bit of an insight into your kind of earlier days and how you went from that into automotive engineering.
Yeah, so growing up in Blythe, it's not the immediately obvious industry that you would have expected someone to actually jump into. And after thinking of several areas that I was interested in, I actually drawing cars and being involved in seeing how people move around was such an intriguing challenge that I decided engineering was what I wanted to do. Long story short, through Teesside, going through a design training and then moving to Coventry, where I finalized my engineering degree. That sort of brought me quite nicely to the Jaguar Land Rover experience as it was.
Okay, yeah.
It was actually Rover Group at the time, and Jaguar was just down the road, but there was always been very clear links to it. And so I decided that car design and car engineering was something that I wanted to do. So, right. You know, that's the transition from really an idea in the Northeast all the way through to delivering some pretty amazing products through my career up till now.
And that was, if you don't mind me saying, that was quite a long time ago. In the nicest possible way. No,
it's too many years, almost 30. So, you know, that's the sort of, the numbers are going from 20s to 30s. That's scary.
So you went through that, BMW, then to McLaren. So quite early, obviously not into electrification at this point. So quite almost the opposite end of the scale at McLaren with some of the products that you were working on there. What kind of things were you doing?
Yeah, so I joined a very, very small team in McLaren Automotive at the time, under some extremely influential engineers in Barry and Gordon and Frank, who needed to actually bring a team together to deliver what was called SLR for Mercedes. And it was at that period of time, Mercedes were looking for a partner to actually develop their supercar technologies. And I was lucky enough to be able to join the team, one of six, to actually create the engineering structure that, in most instances, from a design perspective, from an engineering perspective, still exists today, albeit that it's at a much larger scale.
Yeah, well, yeah, definitely. And just to sort of put sort of full names to those, Barry, Gordon, and Frank, not people that would be quite well recognised with a full.
Yeah. So Barry Lett obviously was the head of engineering and design. Gordon Murray was the figurehead and the inspiration. Yeah. So yeah, they're sort of two of the inspirations for me when it comes to actual product design. And then product development, Frank Kopuk, who's a very influential Formula One designer from some time in the past, and has been able to bring through an awful lot of development technologies and development methodologies into mainstream operation. So some pretty amazing people I got to work with in McLaren.
It must have been a fantastic experience. So after you were at McLaren sort of 8 or 9 years, you then came home.
I did. I moved back to the Northeast. I saw an opportunity, and I was looking for maybe a more sustainable future when it comes to just technology in general. I think after the awe-inspiring experience of working on such a performance-driven product, you get to realize what the art of the possible is, and you expand your horizons, I think, accordingly. At that point, electrification was just an idea.
Yeah.
A company called Modec was doing some amazing things to demonstrate the availability of electrification in commercial vehicles.
Yeah.
And Smith wanted to do the same thing, and saw an opportunity to do it as a larger scale, more recognizable use of current technologies at that time to do it. So I moved back to the Northeast to do some what would be quite an expansive range of commercial vehicles in the end.
Yeah. And that so people might not actually recognize the name now, because it is Smiths were around and then kind of went, but Smith's history goes back a really, really long time. Essentially, Smiths were making electric delivery vehicles for delivering tea and milk and things back in the 1960s. The business Sevcon, which is now part of Borg Warner, span off it. Sevcon was Smiths Electric Vehicles Control Systems. But then in the kind of 2005-06, the Smiths electric vehicles business was bought out by Tamfield Group, and they essentially came up with this the strategy to move from the kind of low performance milk floats and airport tugs and that kind of thing into on highway, like high performance electric delivery trucks, electric delivery vans, and a massive, at the time, this was revolutionary thinking, really, because we were still, this was early days of Avid, and, I remember regularly having people kind of tease us about milk floats, which in other countries, people don't know what milk floats are, but it's a very English thing. Very, very slow electric vehicles that used to drive around delivering milk at 4:00 in the morning. It was completely actually visionary idea at Smiths that you could take those principles and apply them to full scale commercial vehicles and deliver a product. So, do you want to just where do you even start with the Smiths journey? Do you want to tell us about that?
Well, I was inspired by the leap that could be created by just taking a focus and delivering against an objective. There wasn't any excuses. That was all we did was electrification of commercial vehicles, and we weren't trying to solve everybody's challenges for every single application. We just recognized that last mile applications could be very much delivered with a zero emission at point of use by electrification, and the technologies existed, the energy densities existed at the time, the electric machines existed at the time. They just weren't being applied because everybody was focused on cars, individual people transportation, which in essence extremely important and has taken a while to mature and is now becoming the mainstream transport application. But in parallel to that, commercial applications were consuming and still do consume a huge amount of carbon. And they actually do put a lot of burden on all of the infrastructure systems that need to be resolved as well. And so focusing on that, we delivered our initial demonstrator to a very visionary business in TNT who recognized that they needed to do something different to survive and be able to deliver their products and to do their services in an economical way. And that it progressed from there. In the end, building over 1,000 electric trucks in initially UK, but then ultimately also moving to manufacturing trucks in the US, where FedEx, UPS, are all looking at doing the same journey at a stage behind where TNT were, all the way through to making trucks and vans and buses, small buses for public transportation across the world, Hong Kong, across Europe. I think we demonstrated the capability of the function very well. And that has been the trigger for others to come in. And I look carefully at the technologies and the products that are being offered to the marketplace today, and whether or not it's a Mitsubishi Fuso truck that's now the first electric truck ever to be existed, because there's been quite a few of those.
Yeah.
They're all doing an industrialized level of what was being developed and invented, let's say, in a number of businesses across the UK at the time.
And this was so effectively the two products that emerged at Smiths were the what was it, the Edison and
we did Edison and Newton, really.
Newton, that was it. So the Edison and the Newton were the two products that emerged out of it, and these were taken kind of. So you basically decided that you weren't going to develop the chassis and all of that stuff from scratch. You were going to do a conversion. So you're working with the Ford Transit and what was the larger truck? That was the base vehicle from someone else, wasn't it?
Yeah, just strange enough, the large truck was from a company called Avia in the Czech Republic.
Right.
Which, surprisingly enough, I'm not that far away from today.
Right. Okay. And particularly the transit conversion, because it's, I think, the latest announcement for a reverse merger US listing SPAC thingy-mabobby, which there's a lot of at the moment, is a company, it was Lightning Systems, and they're basically doing electric conversions of transit vans. And I saw some of the press and pictures of the build process, and honestly, it could have been a picture from 12 years ago at the Smiths plant. So
the Vigo Centre.
Being you guys really were true trailblazers in that sense. But that must have made it really hard to do what you were doing. What were the kind of challenges?
Well, sometimes they say that to be first is to be. It's not best to be first. It's sometimes best to be second. Clearly, the vision or the philosophy behind what we were trying to achieve was inspirational, and it did deliver against a lot of the objectives that we set out. It's the other things that you need to solve to actually get you to that date and to get you to that demonstration that obviously we solved through muscle power, brain power, just general sweat, which others have learned from. I wouldn't have said the biggest challenge was going to be availability of connections and fuses.
Right.
Now that just sounds like a stupid thing. But in reality, everybody was focused on batteries and electric motors and things like that. And you can, magnetic developments were all being imagined as to get increases in energy density at the electric machine level. Batteries were being forced in terms of their development, and it's still happening today, to actually improve their chemistry. Yeah. The actual integration and the challenges associated with making it safe and serviceable and sustainable and cost effective. Yeah. Those obviously were the things that you have to layer on top of any of these innovations. And they did take some time to actually resolve. Yeah. And that's where first mover status sometimes isn't really helpful. Second mover status can come in, sweep up all of the good bits, not forget all of the challenges, and not have to learn the lessons that are learned by others.
Because you would have to spend at that point, and I can remember just about how these were done, but even things that would be simple today, like how am I going to plug into a high power charger? Today you go and buy your CCS connector. It's an accepted standard. There's a number of suppliers, but back then they didn't exist, and you guys were having to come up with how do we have like a reliable, safe, waterproof way of plugging into a high power charger?
Just the Mennekes connectors were obviously they didn't really exist. at all. The sealed drive-over connectors that now exist. So we were, you could have a look. The big blue connector, big red connectors that are industrial connections. We had to use those to start with.
Yeah.
Because that was all that was available in the current rating that we had. So, it was definitely something that opened my eyes to, again, just what was possible with just effort and how you could take on a task without having the book.
Yeah.
The book can probably now be written on how to do an electric vehicle.
Yeah.
But when you and I set out, there was no book. There was literally lots of people going, that's going to take 25 years. That will never happen.
Yeah.
We'll just carry on with emissions control and improving emissions. In the end, now I think we could write the book.
So solving all these challenges, getting reliability to the right place for the commercial fleets particularly, because that is a bigger challenge with compared to a passenger vehicle where you might have, design life of a couple of thousand hours. A commercial vehicle is a much more difficult application where you've got to do thousands of hours a year, let alone across the whole life of the product. So getting all those reliability things and getting the vehicles running right, that kind of those challenges were quite significant in the end, weren't they?
Yeah, I think sustainability and reliability comes from a number of places. It doesn't necessarily simply come from somebody checking it's okay when it goes out the factory door. And the supply chain had to grow immensely to actually be able to deliver the likes of the performance and the reliability of those products that could deliver ultimately on the customer satisfaction. And any one of those elements, if it wasn't reliable or if it didn't meet the objectives or it had some level of sensitivity, certain environmental conditions or whatever else, it caused the customer dissatisfaction that while in the 80s and the 70s, it might have been accepted because vehicle reliability was of the similar level. Yeah. By the time we were introducing vehicles into the marketplace, you don't think about whether your car is going to start when you go out on a frosty morning or not now. It's just, it always will. And you don't even have to worry about it. Yeah. And that sort of, that step down in terms of reliability and availability at a commercial level was unsustainable. And that's the biggest challenge. I think it's not about whether or not it's 100 or 120 kilowatt hours of battery available on the vehicle. Yeah. It's actually about, can I use what I've got? Can I always turn it on? Can I always do the job that I need to do with it? Yeah. Can I forget about it in terms of its maintenance because it's already matured and it has that reliability?
And a big part of the way that you get that reliability is through, obviously engineering time and testing and validation work. And I guess you must sort of raise an eyebrow when you see other commercial vehicle people coming to market and they maybe don't have enough budget to do that sort of thing. Or on the other side, do you feel a pang of almost regret when people like Rivian are out there and they're raising billions, so 3 billion or whatever now? I mean, that's effectively you need significant investment to get that reliability and the supply chain and all stuff into the product. And it's not, 10 million or 50 million, it's like $1 billion.
Well, when you're designing a complete vehicle from scratch, it is $1 billion business. It probably was $1 billion business in the 90s, even no matter now. Yes, there's a realization that you don't get anything for free. Yeah. That you can wait, and if you wait for the next, for another 5-10 years, then all of the individual jigsaw pieces will be available, and it may not be as complicated to do. Yeah. And maybe that is now the case. If you look at just manual service disconnects, high voltage connections, the mechanisms by which high voltage connections are sealed to actual enclosures. Yeah. That's all been solved. It's not as big a deal. The number of hours that, the team put effort into, I know at Avid, but also at Smith, to make sure that we had zero water paths into the actual enclosures, that we had an isolation value that actually was stable and didn't produce false negatives. Yeah. those things, they take the time.
Yeah.
They take the time to develop.
Yeah, with that sort of hours and hours burnt on things like ground fault detection and stuff, which now you just buy a standard module for it. And, we were developing code from scratch for that sort of stuff way back before, and kind of learning the hard way. So the Smiths, I mean, you guys did some amazing work there. And like you said, that the sort of what was Smith still continues today in a number of other businesses, actually, in terms of what was learned and things that have progressed on there. But some people might think, after going through 8 or 9 years, very, very tough, challenging, that you would go for an easy job next. And I say, with the biggest respect, that I had always said to my kind of board that I didn't want to be the crazy guy that had been rattling on about electric cars to then be the crazy guy that started talking about flying cars. You kind of jumped both feet into an electric flying car business, which I can't even begin to imagine the challenge, the challenges involved, and again, not now. This is a number of years ago, when everything was difficult and harder to do. So, Aeromobile, tell us more about that and what that business was doing.
Well, it would have been. I think it would have been very easy for me to take a pause and choose to do something aligned with what I already had done before.
Yeah.
And at the time, it was I had to consider it very carefully. But when you come down to it, if you were offered the opportunity to do something so amazingly radical,
yeah,
and to really challenge the preconceptions of public, the public in general, legislators in general, governments in general, I decided that I really wanted to try and take on those challenges, not simply to develop the product, but also to demonstrate that the future is different. It does not necessarily need to follow a set out path that comes from geopolitical messages or big industries restrictions to what the art of the possible is. You can do some amazing things, and if anything, I don't suggest that with Aeromobile we're equivalent, but Tesla and SpaceX, it's shown that taking on an opportunity, not being too scared about the actual challenge, working through the challenge in a structured way, can do some amazing things. I'm in awe of SpaceX every time I see not only a vehicle take off, but also a booster land. Yeah. If you've seen the videos of SN8 in operation, for a brand new vehicle with a completely different system in terms of control, to do all of what it did in its first maiden flight was phenomenal. And it's because people take on those challenges. And I found Aeromobile was something that actually was something I could really see, if we could get it to work, get it to demonstration, would make people stop and think about efficient use of space and efficient use of time. With too many times I've sat on the motorway on the M1 and thought, look, I've only got to go to get to the M6, and just locally, that's the sort of an example. But if you drive around LA, if you look at various other congested zones, the congestion is because of just the volume of traffic. It's not the journeys themselves. Yeah. And we felt that Aeromobile could offer a different view, and we were probably second in, not first this time. TerraFuture would have probably been first to actually demonstrate that this mobility, this modality could be implemented into a product. Yeah. But I move on it, let's say 9 years from the first ideas of Aeromobile and TerraFuture. Yeah. I was involved with them for 5 years, and we did a huge amount. And in that period of time, where you will now see mobility being talked about with Airbus, with Boeing, with Porsche presenting their ideas about changing from 2 to 3D from the Lilium jet.
Yeah,
they're all technologies and ideas that have, on the back of the base idea, challenged themselves and realized that they can do something different. And we did a huge amount, I think, in actually progressing that market, that opportunity. And Aerobil is still pushing forward with the conclusion of our initial technology roadmap, and the implementation and introduction of vertical takeoff and landing, electrification, complete electrification of the systems on the vehicles, increasing to commercial applications. I'm sure will come with a number of these types of solutions, because the technologies involved will be very valuable when it comes to actually providing a service. So it was a great experience to actually develop those products and develop that team. It was a really interesting experience to pull together the flexibility of and the openness of an automotive set of engineering staff with the complete analytical capabilities of an aviation staff, and to get them working together in a different way. And from both sides of that equation, you could argue that they didn't want to work in a different way, but they had to work in a different way. So bringing that together, I think, produced some really interesting experiences. And well, the product is, one thing that you have to focus on. I've taken from all of my career a huge amount of value in the people and the skills and the knowledge that have come out of the challenges that we've taken, whether it be Land Rover, whether it be McLaren. I see amazing things being done by people that I've had the honor of working with across my career, and they're doing things that I couldn't have imagined. So it's you take an awful lot of value from those things when you're looking back.
It really is. I mean, the Aeromobil is kind of the stuff of dreams, isn't it? It's personal aircraft. That sort of ability to replace on-road passenger vehicles with airborne, like you say, three-dimensional thinking in terms of how we move people around and connect up. But it really, it's something that's been a dream for a long time for a lot of people. But for you to be such a key part of bringing, what is looking like, very credible product into the market. I mean, that's just such a massive challenge to. I think a lot of engineers couldn't even get their heads around where to start that, let alone be actually working through all of the challenges there. So, I do wonder where do you think that market is going to go? So for sort of personal aircraft, do you think that's a space that's going to take off? Boom boom. In the near future, or it does, because I've had this conversation a couple of times with people where I say, right, I went from here to there, and the reason I didn't fly a helicopter was because A, I'm not rich enough to own a helicopter, and B, I'm not skilled enough to fly a helicopter. But there's a lot of things that are happening now with. But if I could, if I had either the money or the skill, there's a chance that I might have flown a helicopter because it's faster, but it's better way of getting around. But everything that's happening with autonomous systems and kind of controls, that's kind of taking away a lot of the skill requirement needed to fly something. If it kind of can fly itself pretty much, then I don't need the skills to do it anymore. And if I can get one of the main reasons helicopters are so expensive is because they make 100 a year, and that's a lot of helicopters. So they're very, very, very low volume product. If we can get kind of volume, like automotive volume, into that industry, there should be some huge economies of scale start to play through.
I mean, I'm intrigued to see where the market will take it and how the desire becomes the reality. Things that have been disablers to this type of mobility in the past, cost, as you've identified, to buy a helicopter costs an absolute fortune, not just in individual purchase costs, but in terms of operating costs as well. Yeah. The complexity of the mechanical systems associated with the helicopter are so vast that, and I look at them and go, just the collective. I'm just looking at the collective going, I can just about figure out how that's working.
Yeah.
And then you've got to put that into the perspective of a maintenance engineer and a design engineer to actually make it fit for purpose and continued operating as it should. Yeah. So the complexity of the machines that were delivering that mechanical type of transportation was an inhibitor, and a very significant inhibitor, because it translated into cost.
Yeah.
When you look at the enablers of how these technologies and how this market is going to develop, electrification is a fundamental enabler. Yeah. Why? Because it actually is reducing the complexity of the systems substantially. I know it sounds like, it's a battery, so how do you make the battery work? And surely it's easier just to use petrol or kerosene and have an internal combustion engine. If you look at the complexity of the control systems for that engine that's actually turning the rotor, it needs a one-to-one maintenance sometimes. Yeah. It needs, for every hour of operation, you probably need to have the vehicle operating in terms of its service sector. So every 10 hours you take it out for a day, and you have to maintain it. Electric machines fundamentally have so few moving parts, so that you can focus in on those things that actually are at risk. Temperature and bearing stability and bearing temperatures. It becomes a more manageable element. So electrification is most definitely an enabler to imagining this. Autonomy, I'm interestingly monitoring the automotive autonomy journey, and to imagine how that is going to come into volumized products, and then doing a substantively good job in actually getting the levels of autonomy for certain applications.
Yeah,
autonomy in flight, it's not as big a deal as autonomy on the road.
Right. Okay.
Proximities, relationship to the terrain, they're more understood, and the separation and segregation are much greater.
Okay. Sorry. So I thought you meant we can have sort of personal aircraft without autonomy, but actually what you mean is it's sort of easier to implement autonomy in aircraft than it is on the road.
Yeah.
Yeah. Okay. Right.
And if you look at it, if you've been in an aircraft in the last 10 years, you will have flown autonomously for a reasonably substantive period of that time, unless the pilot was doing their hours. On certain journeys, there was a journey from Heathrow to JFK where the pilot was in control of the aircraft for 15, I think, no, not even that. I think it was something like 10 minutes at takeoff. They took off manually, and then the rest of it, flying and also landing, was done with an autonomous system because of the nature of the weather at the destination event. Yeah. So autonomy is something that flying has been developing for some time. As distances get closer, so the autonomous operation needs to be more complex, and it has to be. It can't be a service provided to it.
Right. Yeah.
The vehicle has to be autonomous. It can't be the system's autonomous.
Yeah.
So there's work to be done there, but I think they are doing that extremely well. And if you just imagine the swarms of drones that have been demonstrated in operation in various locations, but notably in China, a firework display using drones instead of fireworks is like it's done. There is an ability to actually coordinate some very complex multi-body systems in such a way. So autonomy actually brings that volumization, because you're right, training and pilot confidence is something that is built over time, and I've had the chance to fly. and that natural concern about when you get into an aircraft for the first time.
Yeah.
That is going to be an inhibitor, and autonomous operation and simplification of controls and systems will make a difference, and that will lead to the likes of Lilium of being able to operate without the complexity of the training for a multi-engined aircraft. You know.
And do you see it getting to that point where the product, you'll be able to own a Lilium vehicle or an Aeromobile or one of the others, and you won't have to be a qualified pilot. The sort of systems on the vehicle will be certified to the point where the vehicle is the qualified pilot and you're effectively a passenger when it's in the air at that point. Do you see that's where it's going to, or do you think there'll always be an element of kind of training needed to own a personal aircraft?
Technology can provide that final stage, but society and psychology will preclude it from being the entry point into application.
Right. Okay.
I think pilotless operation is going to be unlikely in operation just because of the safety case. There's a natural tendency to have a pilot in control rather than the vehicle in control.
Yeah.
Because of the uncertainty principle of operating. And the pilot may not have the same level of complex control that you would get with a stick and pedals in an aircraft as it is today, but they will have the ability to interact with the vehicle and say, I need to do this, or we need to take that action.
Yeah.
And so the pilotless operation is a further step.
Yeah.
But single piloted vehicle in control operations for the majority of the time, I think, is the first entry into market that we'll see. And there are a number of vehicles that are able to do that now. Yeah. And are in experimental demonstration phases at this point in time.
And even is it Dubai where they've got an experimental drone taxi? Is it called eHang?
eHang.
Yeah. And that is because actually, interesting thing about that is when you look at it, you think it was pilotless, but actually, if I understand correctly, it's autonomous most of the time. But there's basically a supervisor sitting at a desk somewhere with flight controls should they need to intervene and kind of step in and kind of take over the control. So it's sort of remotely operated pilot's backup for it. But what do you think of something like that? Would you go in it?
I will struggle to get into an eHang.
Okay, yeah.
Unfortunately, with the...
Is that because of your height or because of the sort of technical...
No, I think engineers are difficult to convince of absolutely all of the capabilities of a product, in my opinion. So I need a lot of convincing, and when I look at the aerodynamics of eHang and the fundamental principles of lift, the questions start to pop into my mind. I'm perfectly happy to get into a vehicle that has been designed around the latest generation of VTOL, where you see jobby aviation type vehicles that have that. I can explain to my analytical mind that can fly.
Yes, yeah. Jobby, the guys that just... Are they the guys that have just bought the Uber air business? Is that Jobby?
So Uber have invested in a number of approaches to try and get Uber Air into operation. So this Uber specification has been used to actually trigger a number of types of vehicles. Yeah. Majority of them are going towards the lift and cruise type, where you've got vertical lift machines and you've got a thrust mechanism to actually, and a wing of some sorts to actually create lift during horizontal flight. More than anything associated with efficiency.
Yes.
If you've just got rotating lift machines, then they have to run constant at the speed that you're flying at to maintain the height that you're at.
Yeah.
You turn the motors down, you're going down. You turn the motors up, you're going up.
Yeah.
And when you come to a horizontal operation, that's very inefficient.
Yeah.
And one of the things that we were qualifying in Aeromobile and did a great job of comparing is all the different configurations, which ones are the most effective at which application.
Yeah.
And there is not one perfect answer.
Right.
Whether or not you're doing a 10-minute hop or a 2-hour hop, or are you doing it in different conditions, there are different solutions. So you will see a number of different types of configurations exist for some time to come. And those are backed by big brands and big names. You know, Airbus are showing their next generation of VTOL, which you would expect them to actually have a really good answer to, because they are, coming back to your original point, worried about helicopters becoming redundant when these things come along.
Yeah, that's their... They have a burning platform to sort of do the sort of business speak of actually if someone comes up with it doesn't even need to be all that high volume, 20,000 units a year, let's say, of these personal aircraft. That would absolutely annihilate the helicopter market, which is based on kind of hundreds of units a year. And like you said earlier, these immensely complex systems, flight controls, all the kind of mechanisms and mechanics that make a helicopter work and hang in the air are just so expensive and so complex that then to go to some wing-mounted electric motors that you can make do, pretty much anything you want with some electronic control, and you can rotate them any which way in sort of 5 axes,
And you can switch them off, or you can lose them. The level of redundancy available is, if most helicopters in commercial operations have 2 engines. In fact, all of them have 2 engines. Most helicopters have 2 engines, but privately used can use a single engine.
Yeah.
That does mean that there is no redundancy in certain instances, and you end up having an auto rotate to the ground if there is a fundamental issue. 2 engines potentially allow you to actually maintain safe flight. 8 engines, you can switch one off, and you can still compensate with a control system.
Yeah,
and that's the redundancy level, that a safety factor level that comes with these new technologies allows for much better levels of failure effects analysis to be implemented onto the product.
Yeah, that's a really exciting potential there. And actually, we talked about Aeromobile quite a lot there, but you're, and this I find this is really quite interesting. So you've actually moved on, and you're in a different role, and particularly given the announcements about Blythe recently, and the battery giga plant being built on the old power station site, which you'll have grown up staring at Blythe Power Station, and as much as I did. But you were actually for a year or so now, you've been working for another battery manufacturer based in mainland Europe, building a gigafactory. So at least 2 gigafactories where Blythe's quite significant.
It's a small world, I'd say, when it comes to certain things happening. And I've been I guess I sort of look at the technologies I've been involved in, and flying cars are done in my mind. I know that fundamentally they're not. But you go through
it's too easy now for you.
It's not well, not quite easy, but it feels like there is a roadmap, and there's a path to success, and there's a path to capability of performance. And we have ultimately got to resolve some of the things that actually will prevent these things from being able to be delivered, and energy storage, manufacturing availability of capacity. That's a very simple way of putting why the gigafactories are sprouting up. There is a massive under provision of volume of cells in the European market. And when the acceleration to transfer by 2032, EVs primarily, there is a massive hole. It can't be done without something different happening. And that something different needs to be a European landscape for manufacturing. I say European. I still consider that to be European, including the UK as a geographical area, to make available product that actually can facilitate the sustained growth, even just the sustaining of the top employer of the European Union and the UK when it comes to overall product and their supply chain. Automotive and transportation, it has to be sustained. We have to make sure that it is not diluted or potentially constrained by global supply factors.
Well, the sort of interesting thing, I mean, we've just talked about your experience there. You've gone from automotive, commercial vehicles, personal aircraft. Then outside of that, you've got electrification in the marine sector. You've got more advanced robotics like warehouse robotics, factory robots, all which require batteries. You've got I was reading a huge article the other day about the advancements in robotic lawnmowers. And that's a huge field. But it's a mobile device. It needs batteries. You've got basically underpinning technology to many fields that are now kind of coming through is battery technology. We need energy storage. We need batteries. And that could be grid scale for like renewable projects, could be for shipping, could be for aircraft, could be for electric vehicles, could be for consumer electronics, whatever. More and more things have got, even human beings, more and more of us have physically got batteries inside us.
Well, indeed, yeah.
Medical devices and implements. I talked to a guy from another battery company a few weeks ago, and their sort of field they were really kind of focusing on. One of their fields they were focusing on was medical tech, and sort of batteries for medical devices. So batteries it's a huge market that's growing exponentially. Obviously, there's the EVs are a big kind of thing, and the big driver of that because of the investment and because of the scale. Obviously, you need a lot of batteries in an EV, but it's a huge market that's really starting to grow, and it's one that I don't know. Europe looked like it, even though the lithium-ion battery was it was an invention from a guy who's working in the UK at the time, and so you say it's kind of a European innovation that then really has been dominated in Asia through Chinese, Japanese, Korean companies getting the scale and the production capacity through. So it looked like Europe was getting left behind a bit, but there's been this surge last few years to catch up, and InoBat seems like one of the key companies that's been trying to do that. What's the story? Where did the InoBat thing start, and what's their kind of vision for the future?
Well, I think there are numbers of plays happening in the portable energy storage market, and that's what we're talking about: is how do we make available energy when we need it, and in the right place. And batteries are a really good answer to that question right now. And chemical storage of the potential has something that has gained a, let's say, heading towards a threshold of usability and availability. Yeah. InoBat looked very carefully at how they could best support the development of the industrialization and application of that trend and that technological advancement. And while others are focused on volume and simply manufacturing products that exist today, and allowing the research to happen elsewhere, there's a number of let's call them satellite facilities that are taking chemistry developed in Korea or taking chemistry that's developed in Japan or China, and simply manufacturing. And that's a great way of getting to volume. From a sustainability perspective, I think Europe needs to be more than just a manufacturer. Yeah. Ironically, it's the reversal of what we have been doing as it relates to China. Yep. We've sort of said, oh, well, we'll hold all of the IP here and we'll do all of the clever stuff here. Can you make us some vehicles? And the irony is that now there's a reversal of that. the research did come from the UK. The research did come from a number of Nobel-winning Americans as well. But the exploitation was taken on, and actually the learning of the industrialization has happened in East.
Yeah.
And to be able to do that, we need to bring it back here. So a satellite facility will bring that skill. It will bring that skill back into Europe. With InoBat, we felt that not only did we need to ultimately have the roadmap to get to industrial volumes that would satisfy our customers, we also felt we should take on the challenge of actually bringing and embedding the research methodology so that we can innovate as well. And sustainability in these technologies comes from innovation. In 20 years' time, we will not be talking about NMC.
Yeah.
It will just be a point on a piece of history, and they'll have been recycled and turned into something else.
Yeah.
It will be a new technology. Now, how do we make sure that we've got the ability to leverage that?
Yeah.
I think the only way you can do that is to actually have an intrinsic link to the chemistry development and understand how to what it takes to actually improve energy density. And for the last, I've spent a lot of time with InoBat and our partners. We have a partner called Wildcat Discovery Technologies, who for the last 12 years have been developing chemistry for the battery industry.
Yeah.
And when you get to actually explore the electrochemical development and the atomic development of these batteries, you see another world. It's a bit like opening the Matrix.
Right.
It's a phenomenal achievement that the chemists and the electrochemists have got to already by in what they're doing, to get the actual energy density of the active materials to their potential.
Right.
Or close to their potential. They will never always get right to their potential. That's physical impossibility. There will be a level of losses associated to it. But actually, to see how, from a chemical perspective, you can use research to develop those elements to improve performance. And we want to not only be able to provide cells that are good today, but we also want to have the roadmap to show that those cells are going to continue to develop and to actually mature, and we will be able to provide surety of performance for a multitude of applications, not simply for one specific chosen use case. And if you don't fit into that use case, forget it. Right. Or I sort of try to use the analogy where we say, okay, well, we want to offer you what you want, not what you need. If you want 330 watt hours per kilogram as an energy density, okay, you might only need 270 to just get going.
Yeah.
But actually what you want is 330. The market demands the chemistry development up to 330 watt hours per kilogram, 1,000 watt hours per liter, a reduction in internal resistance. They're all, and I throw these terms out like they're just like, they're sweets, but actually they turn into real customer satisfaction and customer deliverables.
Yeah.
When you can talk about 330 watt hours per kilogram, you can see a vehicle where the weight of the battery is not providing an incumbent load on the vehicle structure that prevents it from actually operating. Yeah. And its efficiency is going to therefore be able to deliver the range that you're expecting. Yeah. Now, when somebody says watt hours per kilogram, you can never believe that means you can go, 350 instead of 250. Yeah. Or watt hours per liter, where you think, well, what the hell is that? Well, that means you can make a vehicle that's got 120 kilowatt hours of battery the size of a Miev in the future instead of the size of a Range Rover now. Yeah. That's shrinking down. So each of those scientific challenges are really, I think, inherently important for the sustainability of battery development, battery manufacturing in Europe. And what I think Europe does even better, and I think the UK will also do a very good job of, is making that sustainability also include the green nature. We call it the green agenda or whatever else you want to talk it. But ultimately, sustainability is the materials. Are they extracted appropriately?
Yeah.
Are they used appropriately? Are they recycled appropriately? Is there any other ethical issues associated with the process of creating energy storage?
Yeah.
And I think that's where I think we will lead the way. I think Europe, as a geopolitical, or just a geography in reality, will force the current manufacturers to recognize their responsibility. Yeah. And to force into them the needs to make sure that sustainability and all of the maybe the less tangible but very important factors are taken into account.
So you're talking about energy efficiency in production and efficiency of the overall kind of process, right from a mineral extraction, mining up to finished product. Getting the embodied CO2 down and all that stuff. So is InoBat focusing on the automotive space, or is it? You mentioned kind of batteries for lots of applications, but is it? Would you say you're predominantly automotive batteries, or is it going to be for lots of different markets, or a different one altogether?
Well, when you consider the sort of the landscape of batteries and the markets that they're trying to be used in now, if you overlay them, I think we've done this internally where we produce a radar diagram of each of the different sectors and against each of the performance criteria. They're very different.
Right. Okay.
They're very different. And what we recognize that we can do is we can use our skills and our research methodologies to target specifically those differences and provide not specifically tailored to the individual manufacturer, although we can do that, but tailored to the application, a performance that will actually deliver the energy density that is required for let's say a BMW that has that weight sensitivity, but also can be targeted in a different way to deliver the 3,500 cycles, 7 to 10 year warranty that is required not from the performance sector, but required from a commercial vehicle sector or for a mass market automotive application. So you see that as being a major assister in actually us being able to provide different products to different sectors, and that is a difference in our respect. Our research is simply a tool. But that tool allows us to be much more complementary to different applications.
Okay. And in terms of batteries, one of the other hot topics at the moment is solid state. So is that in your roadmap? Do you have a view on what's happening with solid state technology? Or
so we certainly have a view, and it's certainly on our roadmap to deliver what ultimately solid state actually gives the market.
Right.
So I'm more of I look at it from a process than from a fundamental electronics or electrochemical perspective. And there are lots of challenges in solid state batteries to be able to create the transmissibility and capability of what are very, very efficient liquid electrolyte cells today. However, liquid electrolytes are inherently challenging in terms of their processing.
Yeah.
They're an element in itself in terms of cost.
Yeah.
And they're a mechanism by which safety issues can be propagated.
Yeah.
And solid state actually does try to inherently respond to that by replacing a separator and an electrolyte with potentially one interface between the anode and cathode. So from a process perspective, it makes much more sense. Makes sense.
Yeah.
It delivers simplification assembly, a process that actually is one of the bottlenecks. One of the major elements of a cell manufacturing process is the vacuum filling process that actually occurs. You can remove that completely, or if you can simplify it significantly, then you're going to be able to increase throughput. and the cost is going to be able to come down.
Yep.
Now, materials themselves at this point in time are still too exotic and too early stage for the price to be imagined as coming down today.
Yeah.
And we have to continue with our roadmap for liquid electrolyte cells. We are doing that, but at the same time, we're also monitoring and researching elements that will improve all the way through to and including solid state. But it's not just limited to that. You can talk about pre-lithiated anodes where energy density of a standard cell currently would be improved. That's something that is being done more and more. There's, I'm sure you will hear stories of lithium metal anodes, and the processability of lithium metal is inherently difficult.
Yeah,
it's more like butter than metal. So the actual control of it is somewhat difficult. But ultimately, if you can imagine applying that and protecting it, then your energy levels at the anode are going to go up substantially.
Yeah.
So we need we've got a technology roadmap that gets us as far down the, let's say, liquid electrolyte roadmap as possible. While in parallel working on these replacer technologies that will come along. And, you could probably list 10, 12 other replacer technologies that, if they are fully successful and fully industrializable, would be a replacer for what would be called an NMC roadmap today.
Because there's sort of interesting developments at like a chemistry level, but then you've got the process-orientated stuff. Solid state is probably a combination of process and chemistry. But there's some pure process things like the move from wet slurries to dry anode cathode production. So there's lots of stuff going on at the moment. It must be quite hard actually because you're not talking about small investments either in these plants. It's huge, like multi-billion investments in these big plants. So keeping abreast of all of that and making sure that you don't end up putting a foot wrong must be quite a challenge.
I mean, the fear of redundancy obviously is quite a focus for making good decisions.
Yeah.
Because we don't want to invest in chemistry or mechanisms or machinery that actually is going to ultimately prevent us from being able to exploit new technologies as they come along.
Yeah.
There will always be those technologies that do come along where you need to have a shift of certain elements of the manufacturing process.
Yeah.
That's expected, and I think we have a view of the maturity and the longevity of our current processes and how they may develop to actually implement new technologies. I think it's the same with all manufacturers, to be honest. They're always looking at, well, what we make today and can we make it tomorrow? And if somebody come along to say, okay, well, you were making it like that before, but now we can do it completely differently, like Tesla. I mean, Tesla are steaming forward with developments not only at a processability level, with dry active materials, a dry application, which will simplify substantially once they have resolved the processing conditions. Slurries are slurries because they're easy to make and apply. Dry powder is not as easy to apply, and you need to solve the problems of that. But subsequent to them doing it, they're going to see a processability improvement. The design of their cells is also something that they've been putting a huge amount of effort in. So the tabless design or cell design that they've come up with, when you see inside it, you can see where they've realized that there is a substantive improvement that they can make in terms of cost if they change the way that they fundamentally do the internals of a cylindrical cell.
Yeah.
And those will continue to occur, I'm sure. We are looking at a number of process improvements that we think are secure, but they have to be industrializable solutions.
Yeah.
There's no point if you could go down the street and see, oh, I've got this brilliant idea. I've got this one cell. It does a brilliant job of doing X or Y. And then you say, okay, well, where's the machine that's going to actually be able to translate that into 6 million cells, 20 million cells? And then you start asking, gigafactories are talking about more than that. Gigafactory volumes are greater than those numbers I've just said.
I guess it's an advantage Tesla has, and some others, that they're kind of learning by doing. And I know one of the things I think in particularly the automotive space that's sometimes a problem is the big OEMs kind of want the perfect solution before they even start. I think where Tesla has started and is kind of learning a lot as it's going, so then making those improvements. And it's fascinating actually, because you've obviously vastly experienced in terms of using batteries. And I do wonder, that's a cheeky question for you perhaps, but how different are the batteries that you're working with now compared to ones that you were dealing with back in 2006, 7, 8 at Smiths? Is there do you wish you had this stuff back then, or is there really not much difference?
Absolutely no. There's been a huge amount of development that has occurred, and there's a huge amount of availability that wasn't available at the time,
right? Yeah.
Which would have made a difference. I have to say, we were. Smith had to look on the open market for batteries and availability of batteries. And as a commodity, lithium-ion batteries, whether they be iron phosphate or NMC or whatever else, there was an over demand. There was too many people looking at too few batteries as the marketplace. So we find it very difficult to actually do absolute product development targeting the customer options, customer requirements, when really you were constrained and stymied by the actual cell that you could get a hold of at the time.
Yeah.
And now that still exists to a certain extent, but it's getting better. And in parallel to that, the nature of the energy density and the price that is available for those has substantially one gone up and one come down. So there is a better capability within the supply chain, and those chemistries didn't exist. I say NMC, and NMC existed when we were building batteries at Smith, but NMC is a ratio of 1:1:1. That existed, and that's an awful lot of cobalt, an awful lot of nickel, and an awful lot of manganese.
We were using some
together.
Pretty racy, they're basically military grade cells, if I remember at the time. The other thing that used to be really annoying, and I don't know if you sort of remember this, but there was no standards. So every time, even working with the same blooming cell manufacturer, they'd come up with something new. Say, oh, we've got this new cell, it's this better spec. It's going to solve these issues that we had with the old cell. And every time they'd change the size of the damn thing. So you were you spent all this time and money engineering a battery pack around a certain pouch format, and then they'd come out with some very small incremental improvement, but they'd change the size of the pouch by like 3 millimeters. Go start again. Whereas now the standards, just having a standard cylindrical standard pouches, it's big.
I think cylindrical standardization is going to continue to happen, and it has for a number of years. 18650 being a common format, 2170s has been the norm for ever since Tesla started using it in essence and in volume. They obviously have gone and said, no, we're going to make a different cell again. So their new cell is not a standard cell. Standardization is something that the industry, I think, will be interested to actually achieve once other things have been optimized to the point where they make sense. And I find it difficult to say that we can definitely have a standard format of cell when we haven't got the energy density that we need to provide all of the applications that we need. Once we have that, then potentially that can be optimized to be more standardized into the form factor. But the form factor plays a significant part of the capability of the chemistry. And as the chemistry is developing, so it sometimes is that it would be constrained if you just said we're always going to make 18650 cells. And when you look at the challenge of putting batteries together, putting 9,500 cells together into a pack. Right? That sounds like something that is going to give you a headache once in a while.
Yeah, it's not trivial. Yeah, with,
it's not.
18,000 precision laser welds, and
Yes.
yeah.
and a laser welding head that's got to be monitored continuously and cannot miss one.
Yeah.
So the form factor does suggest that there is a potential to actually simplify assembly.
Yeah.
If you look at the BYD cell, the blade cell is maybe the ultimate for a specific configuration.
Yep.
It's a meter long.
Yeah.
And it's a meter long because it's LFP, by the way. It can't be a meter long if it was NMC.
No, yeah.
But it's a meter long because it's LFP, and it's got terminals down the outside edge of the cells. And it's very simple to put together. They've integrated the cooling and the casing into the way that the batteries are put together so that structural stiffness is achieved within the battery pack.
Yeah.
And therefore, you're not reliant on protection as much as you would have been if it was in you create this battery, but you never want anybody to touch it because it's so ephemeral. Well, now the battery is actually more rigidly constructed. It's bonded together. It has that inherent stability that could, and that's all down to form factor flexibility. But I know from bitter experience, internal installation efficiency is a major driver to all of the vehicle manufacturers, and the cell providers don't tend to help there.
Yeah, and at a pack level, there's always been this trade-off with prismatic, pouch, and cylindrical. What's the best? The blade cell seems like it's. I would almost say it's kind of like a hybrid prismatic pouch cell. It's kind of trying to get the best of both worlds of those. But the argument for cylindricals is there. If you talk to a cell manufacturing or a manufacturing person, cylindricals is like the best way to do it because it's you can zip through it. You don't have to stop your process. But then from a pack point of view, it's not 18,000 welds and all the rest of it. So bigger format cells. So does this seem to this convergence of everyone's got the same problems basically. So Tesla have gone to bigger cells in the 2170s and then bigger again with their new cells. And it's for the same reasons. For that reason, why people like the pouch. But then the main issue then with pouch cells is handling it, and sort of the lack of mechanical integrity to it, and dealing with that, and actually thermal propagation between cells. So it's kind of all these trade-offs and compromises you have to make, and what's the perfect, the perfect packaging format for the cell production machinery is probably not the perfect for the pack designer. It's probably not the perfect for the so a lot of moving parts to keep control of there.
Yeah, but I think if we can, and one of our offerings to the market is we can offer flexibility to discuss what is the best format. It may be that the best format is still 2170,
right?
But you've never been offered as a vehicle designer the ability to ask the question.
Yeah.
Can we do something really cool about the battery? Can we make it run down the pillars? Can we put it into the roof lining? Silly ideas, but no, you can't because the cells are a form factor, and that's it, and that's all.
Right.
So if you've got the ability to imagine making a 1 meter wide battery that literally is a box with cells running laterally across the vehicle all the way down it, then the designer is going to think, oh, can I use that to actually differentiate my product?
Yeah.
Can I actually sell more of my vehicles because I've learned something that other people haven't?
Yeah.
And tailoring does potentially offer that, where if you tailor the chemistry or tailor the form factor, it then offers BMW to think about what's important to BMW, which is not the same as what's important to Hyundai or to Ford. But for each of those, they will have a different answer. They will say, this is more important than this. As a sports car manufacturer, I need to be sitting with my backside on the road.
Yeah.
Okay, so that means the form factor needs to be tuned accordingly to allow that to happen. Whereas if you don't, okay, just let the vehicle grow by 100 millimeters and stick the battery underneath the entirety of the floor.
Yeah.
And you've got a skateboard, and it's really efficient, and you can make gazillions of them and lots of different form factors on top of it, vehicle form factors.
And effectively, is this so InoBat's kind of USP, its business model, is that it's all around that flexibility and the ability to offer more custom solution than one of the other guys can?
Well, we certainly think that there will be customers that need that flexibility.
Yeah.
But even in a standard cell, that we obviously are looking at volumizing chemistry development that is carried out internally within our team, because we see those movements as well being fundamentally important. So it's a mixture of both. We have to remain cutting edge, and at the same time, because of our flexible approach, we could also potentially give flexibility in form factor as well.
So where is InoBat now on the journey then? Are you, what's the plan, and how far are you through delivering on that? What's the current status?
Yeah, it's been a cram-packed 2020 for lots of reasons. But so we have a facility. We've got our environmental impact assessment completed, which doesn't sound like a lot, but when you're talking about the chemicals and the processes that we're talking about, that's a reasonably substantive process of going through.
Yeah.
So we've been investing in that. We're already in manufacture of our initial cell,
right?
To actually demonstrate the chemistry development, let's say.
Okay.
Prior to the pilot line being fully installed, the timeline is that we will, by the end of next year, have a fully installed research center and pilot line manufacturing center within the location, which is about 40 minutes from Bratislava.
Okay, right. And then is that what are the kind of giga plant? Everyone likes a giga plant these days. What's the giganess of your giga plant?
Yeah, everybody likes. Unfortunately, giga will be a word that disappears. I'm sure Terra will take over. But anyway, our industrial volume plans follow in from the nature of our learning that we're carrying out from the end of next year. So our pilot line actually is fully demonstrating our processes that will go into Gigafactory. So it's not just a manual manufacturing process; it's an automated manufacturing process that we're putting into the pilot line. And ultimately, 2024 is our plan for the start of commissioning of our Gigafactory, which could be 10. It very much depends on customer focus as to exactly how large it needs to be in its initial installation, but 10, 20 gigawatt hours. Eastern Slovakia is at least one of the locations that has some substantial benefits,
right,
in both the infrastructure, natural resources, and a capable workforce. So we're certainly interested in exploring how that can be delivered.
Yeah.
That process, however, and that time takes around about 12 months to actually conclude in terms of a detailed design phase.
Yeah.
And with most pilot lines, it takes around about 18 months to install.
Yeah. Okay.
Sorry, gigafactories, it takes about 18 months to install.
Right. Okay. So you're kind of you're well on the way. And is there? Are you starting to get customer traction now for sort of people signing up for capacity in the future and what have you?
I think you mentioned the reticence of the industry to actually to commit until everything is done. That's something that I think the industry needs to recognize, that if we're going to increase volume substantially, they need to get on board. And because of that, that was one of the first things that we did, was to go out to customers that could be securing gigafactory volumes for us from us in the future, and to get their impression of what we're proposing to do. Received an awful lot of feedback very early on that's allowed us to actually tailor what we've proposed and how we're actually approaching it to those high volume off takers. And as you say, mobility is a very broad sector. Mainstream automotive mobility is probably taking a planned 70% of all capacity in gigafactories going forward. Right. So we have that as part of our story, part of our narrative, but at the same time we also have the narrative where we can be supporting other sectors, both through manufacturing cells at gigafactory, but also potentially also selling production cells out of the pilot line, where we'll have around 250 megawatt hours of capacity when we start production there.
Wow.
So I have that flexibility and also the mass scaling option as well.
Yeah. Oh, wow. So it's a significant pilot line in itself.
Yeah.
So what for you then, moving from being very much on the vehicle side of things, what has it been a challenge to go to battery and battery cell development and manufacturing? What have been the challenges for you there?
I think with anything new there is a challenge, but I think we the reason I thought that I was able to add something to it is I had context.
Yeah.
So I already got the pain from the other end of the story, and had been involved in the chemistry roadmaps and chemistry stories, even as a customer for some time.
Yeah.
The challenges do exist where I need to get from the component level to the atomic level, and learn exactly how to make good decisions when you're working on optimizing at that level for a product that ultimately won't be experienced until you see it at a pack level.
Yeah.
But the team that we've got around us here is really well informed, both from research chemists all the way through to some of the leading applications engineers in the automotive industry. Far more experience than I have, which is good, because they have a view of the BMW and the Porsche roadmaps to success as well.
Yeah.
As well as the other new entrants to the market as well. So it's a great team that creates some really interesting and quite accelerated development, I have to say. We've moved a long way very quickly.
Oh, fantastic. And I just kind of I just noticed the time actually. We've kind of run over. So finally, what are you most excited about for the future? What's kind of happening for you and for InoBat that's really got you excited for the next few years?
Yeah, I think InoBat's future is looking extremely positive, and getting the first customer to experience the product will be something that will be really a great thing to experience. We've already seen some cells manufactured. That was a really good positive for the team, who have not really understood what it's like to bring something to fruition before, and from nothing to something is an experience in itself. So I'm most excited to see the team grow and to realize their potential in terms of the really what can be achieved when you put your mind to it as a group. So that's really enthusiastic. I'm interested in a global level, or at a regional level at least, to see how electrification can fundamentally change people's perception of transportation and applications of product, and how the automotive industry and the other transport industries evolve to take a lead again in actually where those chemistries and those opportunities exist.
Yeah.
Whether it be in the end, is hydrogen going to take over from certain applications?
Yeah.
Is battery a stepping point when it comes to large scale commercial vehicles? There are questions that are still to be answered, but it's a really exciting time when this level of change is imagined and accepted as being a good thing.
Yeah. Oh, brilliant. Well, thank you so much for taking the time out, Doug, to talk. Really, really good to catch up with you. Fascinating to learn more about what you're doing at InoBat, and also get the benefit of your experience for the listeners to the podcast. So thank you. Thanks for taking the time out.
Not a problem, and hopefully we'll be able to. I'll be able to get back to the Northeast at some point in the near future.
Yeah,
I'll be able to visit my mother, who's in lockdown and isolating. But it'd be great to see the Northeast and the sea again. I haven't seen the sea in 8 months, 9 months.
Oh wow, which for a Blythe boy is pretty hard.
And that's like, you don't, I keep on watching videos on the TV, on YouTube, just to see it.
Oh, fantastic. Great. Well, so that's all we've got time for today. Thank you very much to everyone for taking the time out to listen to the show. I hope you've got something from this. Don't forget, if you're doing something really interesting and exciting in the world of EV or AV, just like Doug, then you could be a guest on the show too. We've got some really exciting episodes lined up. Don't forget to subscribe. I checked out the statistics the other day, and it was quite surprising, actually. We've got a lot of subscribers, but it's something like 10-1, the ratio between people who are subscribed and people who are actually listening. So please do subscribe. It really helps the show get in front of more people, helps all the algorithms and stuff, and it puts it in front of the right people when they're looking for good information on electrification and autonomy. So that's all we've got time for today. I really look forward to speaking to you again soon.